So my agenda here is first, I'll cover 4 high-level integration usages, then event enabling your integrations, and finally, a recap summary of what I covered. So let's go into the 4 high-level usages. The first one is application integration. In the past, you might think of this as keeping data in sync between applications. But more and more, we're seeing a more what I call a more mature version of application integration, which is using integration to create digital building blocks of your business capabilities. A second one is data integration. This is as data is produced, you want to move it somewhere, maybe transform it as it moves to get it in a place where you can perform analytics, gain insights, make better decisions. Third one is B2B integration, just integrating with your business partners. We're all familiar with that, hopefully. And a newer one, particularly for iPaaS, would be business process automation. Let's dig into each of these 4. First one, application integration. What are some of the key components you need for application integration? That would be API management, event streaming, iPaaS, and a service mesh or something similar like Dapper. And there are other things that can support it, but these are the 4 main key pillars. So event-driven architecture, what is its role in application integration? Decoupling microservices and business domains is a very important role. And also, I mentioned digital building blocks before. Usually that's REST. We're seeing a trend where more organizations want to make event streams that are also digital building blocks that are as important as REST in their digital strategy. I'll talk more about that later, so let's just kind of hold that thought. Data integration, the second usage. There are many key components for data integration. I won't read them all off here, but iPaaS and event-driven architecture are 2 very important ones for data integration. And specifically for events, I want you to imagine all your business events happening right now in production. And just imagine if all of those events were easily accessible in real time across your entire enterprise and to your business partners. How powerful would that data be? And that's the power of event-driven architecture as a component of data integration. It shuttles data all over the place in real time and making that easy to tap into. Because you can shuttle it in real time, but to one destination, but if it's hard to plug in a second and a third, a fourth destination, you're not really agile. And so real time is very important. I alluded to that in the previous slide, but why is real time data key to data integration? Well, it's because the time to decide is shrinking. Data is useless if you don't use it to make action. And the path that is data is originated, you perform your analytics, you gain insights, you make a decision, and you take action. But the time between when the data is created and when you want to make a decision and take action, that is shrinking. The nightly batch cycle is too long in many cases. In fact, you may need to take action within less than a second. And if you aren't taking action in the appropriate time window, you have outdated insights, poor decisions result, and impotent, if not harmful, actions. So real-time data is key. Event-driven architecture is a important component of real-time data integration. EDA's role in data integration is data replication, real-time analytics, event broker plus iPaaS for ELT, that's extract, load, and transform. This is an alternative to ETL, extract, transform, load. And we're seeing a shift more away from ETL and towards ELT. I'll dig more into this in the second section on how these 2 complement each other for ELT. And event-driven architecture also straddles both app and data integration needs. I'm publishing an event to applications, and those apps respond by executing some code, some process. That feels like app integration, but also a lot of data is being shuttled in these events. It can go to analytic data stores. So organizations that have a strong app and data integration need can kind of get the best of both worlds by using event-driven architecture as part of their integration strategy. Next one is B2B integration. The key components for this I have on the screen here, API, EDI, etc. Now, I don't have event-driven architecture here because I'm just listing what I'd call the key must-have pillars of B2B integration. EDA is relevant, though. It is in a supportive role for B2B integration. You maybe don't always need it, but there are times when you may need it. And so EDA's role in B2B integration is, again, increased need for real-time data. That's not just for you. Your business partners also need real-time data. We see a trend where partners will insist on real-time delivery, and events are a great way to do that, replacing your nightly batch managed file transfers. That's actually a pretty common inquiry. How do we replace managed file transfer with real-time data? My answer, think about event-driven architecture. And also growing interest in partners receiving events. I've worked with clients where they say, my business partners, they want me to publish events. They want access to my event broker, or they want me to publish events through something like a webhook. It's growing interest. I wouldn't say it's the norm, but it's growing, and I expect it to continue to grow. So definitely a trend you'll want to keep on your radar if you're not yet seeing that with your business partners. The fourth one is process automation. This one, again, I'll put on the screen here some of the key to this. The APIs in event portals are the more important part of this when you think about events. The creation of events may be less so, is more supportive, but the event portal is key here because the process automation is often done by citizen developers. And citizen developers need a place to go to discover your digital assets they can plug into. And that's not just REST. That's not just an API portal. You also need an event portal because many business processes are triggered by an event. And so the citizen developers who are doing process automation need to discover events and be able to onboard to them self-service without having to make a bunch of phone calls to different IT departments. Hey, where can I find this event? How do I get access? They should do that self-service. And so that gets to EDA's role in automation use cases. And that's building blocks for citizen developers to tap into. And again, the event portal is key for this. Next, let's move into the second section, event enabling your integrations. First, I want to draw a contrast between speed and agility. Speed is going fast when knowing your destination. And speed is important, but it doesn't always work because where you think you're going isn't always where you end up. Agility is going fast when you don't necessarily know your destination, or you can think of it as the ability to rapidly change directions. This is important because disruptions occur in your market. I know we're sick of hearing about the pandemic, but that's the poster child for this. Pandemic aside, markets are being disrupted. Not just disruption, but new opportunities. Something came up that no one imagined that's going to be a huge opportunity, and you want to get there before your competition. That's agility. And agility is what drives most of architecture. I would probably argue all of architecture is about agility. And integration is a key part of achieving agility. And within integration, event-driven architecture is a key component of that. So let's dig into some of the integration patterns that involve event-driven architecture and how those improve your agility. So the interplay of EDA and integration for agility, one is that they are foundations to EDA and integration are both, when I say integration, maybe think like iPaaS or integration platforms, orchestration tools. They are foundations to agility, among some others. I'll talk more about that. Also, events for resilient microservice integration. Microservices are also key for agility, but you cannot have resilient microservices without event-driven architecture. EDA plus iPaaS for ELT pipelines. You can make better ELT pipelines by having these two complement each other. And fourth, using domain-driven design to influence your integration styles. There's orchestrations, your traditional integration through tools like iPaaS, and then choreography is your event-driven integration. And these two work well together to improve your agility, particularly if you're taking a domain-driven design approach to your integration, which you should be. All right, so foundational solution architecture. In the past, Forrester promoted the notion that where things run to support agility are containers and cloud platforms. That's still the case. But central to agility is how you build things. That's API microservices in the past. That's what we focused on. But events, especially the past year and a half, have very much emerged as also central to how you build things for agility, and integration. Your iPaaS integration platforms are also central to that. All right, so I'll talk a bit about how these things interrelate with each other. First is APIs. APIs provide you strategic agility by creating a modular business platform. Your APIs that you see here on the screen here, you don't see the word application. So for example, issue card, money transfer, these are business capabilities. It's the money transfer business capability, not the money transfer application. That's the appropriate way to be designing your APIs. And when you have these business capabilities exposed through APIs, you can assemble them and reassemble them in new ways to advance your strategic business objectives. That includes ones that weren't on your radar when you created the API, hence the agility of using things in ways to go in new directions that you weren't expecting, being able to change directions quickly. Now, the challenge here is that, again, these APIs should reflect the business capability, not the underlying systems, but you still have those underlying systems behind those APIs. That's the messy IT behind your APIs that need to be stitched together to produce those clean interfaces. Well, iPaaS is integration platforms are a great way to do that. Not the only way, but it's a very important part of creating those clean, business-oriented interfaces. So that's how an iPaaS would play in there. But where do events play into this? Events also enable modular business transformation. I alluded to this earlier. I have all those APIs, the money transfer API, issue card API. But as they're in vogue, they are generating events, and the outcome of those events are interesting. Those events can be used to advance various business objectives. They can be used for building new partnerships, like the B2B example. And this is definitely a trend we see. REST dominates. I don't want to exaggerate things. REST dominates, but we do see that events are as important as REST when it comes to this modular business transformation for more organizations. Microservices was another key pillar of having IT agility. And I've talked to clients that tell me you cannot do a microservices architecture unless you have event-driven architecture. You just cannot do it. And the reason why is well, it's quite simple. With a monolithic app, I've got this call stack. It goes through memory. I don't think about it, right? And now I've broken up that monolith into several microservices. And these microservices are going across a network. And so I've traded the reliability, stability of the call stack for the unreliability of the network. No matter how good your network it is never reliable. That's one of the fallacies of distributed computing. Classic fallacy is the network is reliable. It is not. And that means that if you have some service that's composed, like an API that's composed of several microservices, it is no stronger than the weakest performing microservice in that call chain. In fact, every new microservice you add to the call chain exponentially increases the odds of a failure. I won't do the math and bore you with that. You can do that at home, but you can take my word for it. And that's why you have to think hard about resiliency when you go down to microservices. And a great way to do that is event-driven architecture to integrate your microservices. If one microservice call does not have to be synchronous, if it is just I'm delivering some message, delivering some data, whatever. We can do that through an event broker. And now, as you can see on this slide, when the event broker has the outage, or not the event broker, sorry, when the service has its outage, the event broker is still receiving the messages that are being produced. And so the client is unaffected, does not even know there's an outage. And of course, when the service is restored for this event broker, then, for the microservice, then it will catch up with the events it hasn't read while it was offline. So there's a bit of a self-healing capability here as well. Next one is EDA and IPaaS for ELT pipelines. Excuse me. So ELT, that is extract, load, and transform. It's an alternative to the traditional ETL, which is extract, transform, and load. Forrester recommends that organizations divest from ETL and move towards ELT. What we see is that ETL is complex. It tends to be batch, which does not meet the modern need for real-time data. Some poor reuse, and also tends to cross-cuts multiple teams. Different teams own different pieces in that ETL pipeline. That really kills agility, because a key component of agility is having autonomous teams that can just move forward and not be dependent on third-party teams. ELT tends to address this. Now, ELT is made possible because many modern data warehouses can actually do the transform themselves. In the past, that wasn't the case. You would have to transform it before dropping it in the warehouse. Now, you can just drop the raw data into the data warehouse and let it handle the transform. And this creates simpler pipelines. The data is typically done delivered in real time. Greater reuse and more team autonomy. Because it's simpler, you don't need as many moving parts to build it, like an ETL pipeline, and that simplicity makes it more conducive for just one team can just build their own pipeline or tap into a event stream and load it where they need and so forth. So let's drill into this a bit. Here is a sales service that is publishing events to a message broker. And I can have the data warehouse subscribe to that message broker. That's an ELT pipeline in its simplest form. Now, maybe this warehouse is more passive. It doesn't have a mechanism to reach out and pull data. I need something to push the data. And so IPaaS can be used for that. That's actually a common way to do ELT pipelines, is put IPaaS between the source of the data and the destination. Now you might ask, well, why not just have the IPaaS go after the sales service directly? Why have the event broker in there? Well, the event broker, it opens up the door for more reuse opportunities. That was one of the negatives of ETL. The complex pipelines are not reusable. They tend to be very coupled with where the data is going. But here, since the data is raw, untransformed, there is more reuse opportunity. And so if I have an inventory service that I build later that also needs sales events, it can tap into this broker self-service. If the sales, and this, it goes back to what I was saying about the resiliency, having sales published directly to inventory, you start to couple sales with inventory for the performance and uptime and so forth. Probably not a good approach. Having the broker insulates the two from each other. And also, if maybe the sales service, maybe that's some kind of a SaaS software, and getting the data out of there is complicated. I don't really have this shown here, but maybe I need IPaaS to pull the data out and put it in the broker. But once it's in the broker, it creates a very simple way to access that data. I don't have to call a bunch of SaaS APIs or whatever. It's just there, easily accessible. And then also B2B partner. Maybe a B2B partner needs this. You could have the B2B partner subscribe directly to your message broker, or some brokers send data out. Or you can also have, again, IPaaS in the middle, where the IPaaS is maybe transforming the data for that partner. All right, so a key point here is that you're using the broker to make the events more reusable as you build the ELT pipelines, and also insulate, like microservices, the producer and the subscriber from any performance issues between the two. Next one is thinking about domain-driven design and how EDA and iPaaS can facilitate good domain architecture. So domain-driven design, the idea is very high level. I have different business domains that need to move autonomously. And the way that works is to have my IT systems aligned to those domains so that domain A, as you see here, has no knowledge of domain B. That's the ideal, no knowledge of the two. And if they still need to interact with each other, which implies some kind of integration between the two. Like how can they interact with each other without knowing about each other? Integration. And these domains typically have microservices in them, which you see as the blue boxes. And so integration is occurring at two layers here. One is within the domain between microservices, and then the higher level in the center, which is what I want to focus on, is between domains. What we see more and more is the desire to have asynchronous communication, asynchronous integration between domain boundaries. In the past, it was almost entirely, or if not always entirely, synchronous calls. It could be a REST API, or it could be a REST endpoint that calls an iPaaS orchestration to transform the data or whatever. But we see more and more demand for asynchronous event-driven communication. And so why is that? Well, let's drill into that orchestration sometimes hinders agility. So here's an orchestration. You could build it in iPaaS. New accounts process invokes it. We update billing. We update customer. Based on the customer update, we run a matching algorithm. Is this a customer we already have in our database, or is this a new customer? And based on that, we'll either send a welcome email or update the customer loyalty for an existing customer. But if I want to gain business analytics insights from that customer match, I want to capture the results in an analytics database, I have a problem here. Who owns this process? If new accounts, billing, and customer are three different business domains, and I'm touching all three, who owns this? Well, maybe the new accounts IT team says we'll own it because we start the process, but they're not aligned with the customer business team that's asking for this analytic data. And so now you have this situation where one business team has to go to an unaligned IT team and try to convince them to say, make my priority be your priority. That's what kills agility. We can address this through choreography, which is using events to, well, choreograph this process. New accounts publishes an event for when new accounts are created. Billing subscribes, customer subscribes, they update themselves. Customer runs this match algorithm and publishes the outcome of that, the outcome of that match. Was it a customer matched event or a not found event? And then email, customer loyalty, they can subscribe and process accordingly. Same business requirement, I just subscribe to those event streams. If I've been granted access, read access to those event topics, I can do that self-service. I don't need to reach out to a third-party team to make this their priority. So that's much better for agility. And the trend that we see is, for knowing when to choreograph, when to orchestrate, is to favor choreography when an integration crosses multiple business processes or teams. Secondly, favor orchestration when integration is confined within one business process or team. And it's not an either-or decision. So the reason why the choreography is favored when it crosses processes, business processes, or teams is those are touch points where you really want to keep things very, very decoupled. And choreography has much better, stronger decoupling than orchestration. But the downside of choreography is it can be hard to see the whole process. How does a message flow from beginning to end? Where is an execution in the process? Has it even finished? Those are much more difficult with choreography, and they're much easier with orchestration. And so when you're within one business process or team, and you don't have a decoupling need between two steps of that process, there's not really a strong benefit for the choreography. The orchestration pattern, yeah, it's coupled, but that's okay because it's a cohesive process, and you get the benefits of orchestration, seeing how they connect together and so forth. But not an either-or decision. So what you often see is that if some integration is going to span multiple business units and teams and so forth, that the first part will be orchestrated. And then when it gets to the point where it needs to cross that boundary, we publish an event. So now we're going to choreograph the handoff between these two domains. And then the receiving domain can subscribe and maybe orchestrate its piece of this, this multi-team process. All right, so to recap the 4 integration usages: application integration, data integration, B2B, and process automation, EDA being key for the first 2 and supportive of the second 2. And a recap of EDA and an integration strategy. Some of the key patterns of EDA. One is EDA and integration foundational to agile solution architecture, as well as microservices and APIs. Resilient microservices, EDA plus iPaaS for better ELT, and choreography for decoupling your business domains.